Welcome back. We've just implemented stun mechanics by creating a Blackboard key called stunned and using a decorator to abort the move to if that stunned Blackboard key is set. In other words, that bool value is true. Well, now we'd like to use our old patrolling code here and have our enemy patrol, in other words, move to the different patrol points and wait in between those points until a particular condition. And that condition can be when our target is set. Remember, when we aggro the enemy, this target becomes set. Now, we can decide whether or not we should patrol or move to the character by using a decorator to check to see if that target value is set. But before we do that, we're going to talk about a new type of node called a selector. Now, we already know about sequences and how the sequence node will execute its children from left to right until one of those nodes fails. The selector is very similar. The selector node executes its child branches from left to right just like the sequence node. However, unlike the sequence node, the selector will continue until one of the child nodes succeeds or all fail. Remember, the sequence node executed its children until one of them fails. The selector will continue executing children until one of them succeeds. Now, let's say our selector attempts to execute this child node here. Now, if this child node succeeds, then the selector will not execute any more child nodes. It will, in fact, return success back to the root, at which point the tree starts over. Now, let's say this child node fails. Well, in that case, the selector will continue to execute nodes until it finds a success. And if this second task succeeds, well, then the selector will return success back to the root, at which point the tree starts over. However, if the selector reaches this last task and it fails, well, then the selector will return that failure back to the root, at which point the root will start over. So a selector node is very similar to a sequence node, except it will execute each of its child nodes from left to right until it reaches a success or all of them fail. So we're going to use a selector node here in our behavior tree. Let's take this sequence here and delete it, and instead drag off of the root and create a selector. Now the selector is going to have a couple of children. Let's drag from the selector and connect with our old sequence here that has all of our move to and wait nodes. This is our patrolling code here. That's going to go to the left. And then we're going to drag off of the selector and connect our new move to node here, which is our aggro code. This is when the enemy runs to the player. Now the selector will execute these from left to right until it reaches a success or all of them fail, at which point we'll start all over. So if we attempt to execute the left branch here and fail, then the selector will go straight over to the right branch. So we want to make this sequence node fail when it's time to aggro the character. In other words, as soon as our target key is set, we want to aggro and chase the character instead of patrol. So we're going to take this sequence here to the left, right-click, and add a decorator. Go ahead and select Blackboard, and we'll get this Blackboard-based condition again. Now I'm going to rename this to isTargetSet. And I want this sequence to execute only if the target is not set. So we're going to set our key query to isNotSet and our Blackboard key to target. Now for notify observer, we can set this to onValueChange. And for observer aborts, not only can we abort self, but we can also abort the nodes with lower priority, which have higher values for their numbers here. So if we want to abort self and nodes of lower priority, we can choose both. So now, as soon as the target here is set, then this sequence node is going to fail, at which point our selector will go over here to the rightmost branch. Let's go ahead and save this and undock it so we can see the behavior tree in action while it's running. Now I'm going to go ahead and hit play, and now we can see that the enemy is patrolling, and if we stay back, then we can see the enemy waiting, and after a few seconds, It's going over to the next patrol point. And keep an eye on the behavior tree down here in this open window. It's showing you where we are in the behavior tree. So patrolling is happening, and patrolling will continue happening until that leftmost branch fails. Then the selector will choose the rightmost branch. So let's make it fail by running up into the agrosphere. And there it goes. The enemy is chasing us. And now that move to is happening. And now I've actually ran outside of the nav mesh bounds volume, which is actually causing us to fail both of these. But we can prevent that from happening by simply having our nav mesh bounds volume cover the entire level. Okay, excellent. This is looking great. Let's go ahead and make this nav mesh bounds volume cover the whole level. So I'm going to select the nav mesh bounds volume here, and I'm going to hit R and just scale this up so that way there is no ground here not covered by the nav mesh. We can hit P, and now we can see that the nav mesh is covering all of the ground here. So that looks great. So we now have a working behavior tree with a selector that will first execute the leftmost branch, and this is the patrolling code. Now, as soon as this target is set, then this decorator, which has a key query is not set, will cause the sequence to fail, and at which point we will abort this leftmost branch, and then the selector will come over here to the rightmost branch, and we will get our move to executed as long as we pass this decorator. And that will only pass if stunned is not set. In other words, if we're not stunned, if stunned is false. Okay, that will conclude this video. We're now well on our way to having a functional enemy. We'll continue in the next video. I'll see you then.